Hi, my name's Jenna Sailor, and this is my Physics 2212 Lab Report 3 on the magnetic field of a bar magnet. Purpose of the lab: to measure the distance of the magnetic field due to the small bar magnet, and to compare the measurements of this distance predicted by equations for the on and off axis magnetic fields from the Biot-Savart law, and also compare these to the computer model. Then, write code in order to visualize the magnetic field of the magnet, and finally answer the comprehension questions and analyze results. Preview. The initial conditions were the bar magnet and the phone when they were on top of each other before they had gone through any movement. The system was the magnet and the phone, the surroundings were everything else. And both models show that the further the magnet is from the phone, the weaker the field is going to be. Some important concepts to know are the Biot-Savart law, and this basically shows the magnetic intensity or magnetic field of certain objects. So right here you can see one of the equations, and then down below is the magnetic field for just our tiny bar magnet, which was given in the instructions for the actual experiment, and that's just K, which is our constants pushed together in just one number to make it easier to write, and R to the N. So for the experiment, we all went through it, so I'm kind of just going to quickly run through what we did. We had to download a magnetic field detector app on our phone and then place our phone on a table so the electric field in the x direction was 0 microteslas. And then from there, we had to cancel out the magnetic field of the Earth, so we were able just to get the magnetic field due to our bar magnet. And then we continually placed it at different distances from the phone in order to find the field. And as you can see here on the spreadsheet, these are all the points from the first part of the experiment that I just described, and it was nice enough to also calculate the average and create a graph. So right here you can see our graph, which is field times distance, and it shows that as the distance is further away, the field gets weaker and weaker. And then down here for the off-axis field, that was the second part of the experiment. We had to place it at a 45-degree angle from the phone. So instead of moving sideways, we were kind of moving up and down by the phone. So I did a few different distances on the same area so I could just get a generalized field. And as you can see, our overall field was stronger than the original one because it also took into account the Earth's field. And even though we did have to cancel it out, as you can see here, by the field by Earth, it wasn't perfect, so it definitely made it a little stronger. Now for the computer model, I'm just going to quickly go over the code. So right here, I had to add in our magnetic moment, calculated that. Just a scale for the arrows so we could see them, the distance. Right here are the different vectors for the axis is perpendicular. And then down here are just a few more arrows to show the magnetic fields and the fields perpendicular and parallel, so on and off axis. And as you can see here, oh, I'm so sorry. Just ignore this right here. But this is what the graph made, or the code made. So you can see our bar magnet, you can see the field arrows, and then you can also see the arrows of the surroundings towards the phone. And then down here are just all the results printed. So we have 2 of our on-axis ones, and then our 4 perpendicular ones. And as you can see, they were similar in the computer model because it was a perfect situation. This was the distance, and that was the magnitude. So some of the observations that we had to make and assumptions that we had to assume for this experiment was that when the magnetometer is far away from the magnet, it measures a near 0 magnetic field in the x direction. And then also that's what we had to do in order to start our experiment. But then also as the magnet moved closer to the reader, the x component increases. So what if you hadn't oriented your experiment to compensate the magnetic north and had instead laid out your meter stick at some weird angle with respect to Earth's magnetic field? So results would have changed by having a higher magnitude because the Earth's magnetic field would have been included in the net total field, therefore increasing it, rather than what we did during the actual experiment where we kind of canceled it out, found what it was, and subtracted it from our results. And the other what if you were to stick 2 identical magnets together and run the experiment again, how would results different? Well, the magnitude would obviously have been larger and increased because we have a larger source. And just going off like perfect scenario, results would probably have been doubled because it was double the source. So finally, some errors. I definitely do have a limited coding knowledge, so if I was better at coding, then the results would have been more accurate. There could have been incorrect alignment of the magnetic pole of the Earth with the iPhone, and we didn't necessarily account for all the Earth's magnetic field when subtracting it from our results. And then finally, there also could have been nearby magnets and sources during the experiment that skewed them a little, such as any technology, any little metal pin. And yeah, thank you.